Tonicity is a term that we use to describe the solute concentration of a solution relative to the solute concentration of a cell. So there's going to be two different solutes that we're really focusing on here. So it will be the solute concentration of the solution and the solute concentration of the cell. And the reason that this is important is because this tonicity will help us to predict the direction of water movement. So osmosis is really what we're talking about here. Recall that with osmosis, we were describing the direction of water movement across a semi-permeable membrane. And that is certainly what we have surrounding the outside of a cell. The direction of osmosis was influenced by the solute concentration of those water-based solutions. So with tonicity, it's really just another look at osmosis, but now we're talking about it relative to a cell. And specifically, it's going to tell us, will the cell gain or lose water? Okay, so in other words, is water going to move into the cell? Is water going to move out of the cell? Or is there going to be absolutely no difference at all in the direction of water movement? So when we talk about tonicity, we have essentially three different solutions that we can refer to. So all of these terms, isotonic, hypotonic, and hypertonic, they do refer to the solution that is surrounding the cell. If we look at the prefixes, the prefix iso means same. So what we're saying here is that the solution has the same solute concentration as the cell. If that happens to be the case, then if we have the same solute concentration in both compartments, the solution and also the cell, then we would expect to have the same free water concentration in both compartments. So what that's going to do to the direction of water movement is it's not going to affect very much. So the green is representing the solutes, but there is going to be water here, and we will expect that some water is going to come in and some water is going to go out just because we are at equilibrium. So we will have some water moving in both directions, but we're not really going to see the cell overall gaining water or losing water in this case. Now, if we switch and we talk about the next solution type, that's the hypotonic. Well, hypo means low. So what we're saying here is that the solution has a low solute concentration compared to the cell. And now we want to think about what that's going to do to the free water concentration. So remember that we do have an inverse relationship between the amount of solute and the amount of free water. So on the outside here, if we have low solute, we would expect that we're going to have high free water when you compare that to the inside. So the inside has high solute, but the high solute means that we're going to have low free water. So water is going to diffuse down its concentration gradient. So this is osmosis. So osmosis, the solute is not moving across the membrane itself. So if the water is going to diffuse down its concentration gradient, we're actually going to see the water move into the cell. So we're going to have water moving in, and the end result of this is that the cell gains water. Now, how much water the cell actually gains is really going to depend on how different the concentrations are in the two compartments. Because remember that diffusion or osmosis is going to occur until we get to that equilibrium point. Now, in some cases, too much water will move into the cell and it could actually cause the cell to rupture or burst. Or another term that we use for that is we could say that the cell is going to lyse. Okay, so that is another way of saying that the cell is actually going to burst. That is going to be a deadly situation for a cell if that happens to occur. The third solution type that we have begins with hyper. Hyper means high or over. So what that is saying is that the solution has a high solute concentration, and this is going to be, again, compared to the cell. And this is important because, again, this is going to affect the free water concentration in the two compartments. So if outside we have high solute, then we expect that we're going to have low free water, because again, this is an inverse relationship. On the inside, we have low solute, but that also means that we have high free water. So again, the water moves down its concentration gradient, which in this case means that water is going to actually leave the cell or move out. So what this means is that the cell is now going to lose water or get dehydrated, would be another way to say it. How much water moves out, again, is dependent on what the solute concentrations actually are. So the water is going to continue to move out until we end up with equilibrium, or the same concentration of free water on the inside of the cell compared to the outside of the cell. So you could end up with a very shriveled up cell in this case. Okay, so just to review, when we're talking about tonicity, really it is a look at osmosis. We're now just looking at osmosis, considering the solution surrounding a cell and whether the water is going to want to move in or out of that cell. But it is the principle of osmosis, so it is the solute concentrations in the two compartments that is going to affect the direction of that water movement.